Okay, I have a tendency to talk really, really fast and do a lot of this. So just look at me and do that if I tend to speed up. But I'm Rob Readling. Most of you know me. I'm the Network Operations Manager. I'm going to try to get in a place where you can see this really briefly to give you an overview of what the network ought to be, how we see it, and then maybe a slide shows what we're going to be doing in the future. And if you've ever been to a Cisco presentation, they have about 800 slides. I have 10, so I'll try to do better. So the big question I put on here is, what is the network? Because every time I get a call, the network is down. No matter what it is, the network is down. And so I want to try to clear up what's the network. So let's go right on. These slides will be available. I'm not going to read my slides to you. So I put Merriam-Webster, what their definition of a network is. It's kind of dry, it's kind of bland, it's kind of boring. Doesn't really tell you anything. And I said, that's nice, but we need a model. So I mean, I'll go through this. It says a system of lines, wires, etc., that are connected to each other, a system of computers and other devices. Really kind of, so what? So what does it do? What is it really? So I get this model. So this is called the Cisco hierarchical network. That's a tongue twister this time of morning, as much coffee as I've had. It's comprised of 3 layers, and when I say logically, I mean 3 logical layers as in not necessarily 3 physical connections. I'll get to the point in a second with that in the next slide. But I'll read my footnote. It simplifies the task of building a reliable, scalable, and less expensive hierarchical network. And I will say this, at Elon, we tend to have kind of, I call it an agnostic stance with vendors. I don't want anybody to think I'm giving the Cisco Kool-Aid speech here today. But the Cisco model has become almost synonymous with networking. It's simple, it's easy to understand, it's easy to relate, and so that's why I use it. So I mean, I promise that it's probably the only slide that says Cisco, I swear. So I don't want to give a commercial for them. Well, I'm sorry, there were 2 slides, my bad. So I haven't seen these since Monday, give me a break. So the first layer, do we have a laser? You can't see it anyway. The first layer is the core layer. And just a little blurb in here, it's concerned with high-speed switching, and I'll get to that in a moment. The second layer is the distribution layer, and that's where all our policies happen, like who can go where, how fast they can go, quality of service. And then the last layer, which is the layer that's in every building here on campus, is the access layer. That's where your computer plugs in, that's where your phone plugs in, that's where your access points plug in, video cameras, you name it, that's the access layer. It's well named. It's how you access your things. So let's go through the core layer. The core layer is only concerned with really that one big item right there, moving large amounts of data as fast as it possibly can. It doesn't care who sent the data. It's not prioritized. It's just concerned, it's like the clover leaf in Texas, a big interstate. That's just get as many people through there as possible. It is an 8-lane highway. So that's what the core does. But it must be redundant. The core has to have built-in fail-safes in case something goes wrong. It has to have an alternate road, so to speak. Without that, it's not very good as a core. It must be reliable and have built-in fault tolerances, low latency. Again, that data has to just think of it as a huge funnel and just boom, 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 boom with your data. Quality of service processes are there. What is quality of service? Am I speaking over everyone's head when I say quality of service? Probably. Show of hands, you guys know what that is? Okay. Quality of service happens here as far as the data on the network has already been marked as having a certain priority. And the core just says, okay, fine, go, 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 go. There's no there's no marking going on here. It's already done. It knows where it needs to go. It just needs to get there. Has a limited and consistent diameter, and I underline that word. Diameter, the definition of that is the core has a definite boundary. It's limited by the number of hops, and by hop I mean from one device to the other. So while the core is logical and it's physically connected to other things as well, it doesn't go on into infinity. The core stops somewhere, and what you may find in a network is it's not necessarily a circle like the first diagram, but it's interlocking fingers. That's how it sort of connects to the other layers. So it's very important we don't let the core go out into infinity. Example of core here, layer 3 switches, routers, gateways for voice and video. Those are good examples of core devices. Very high-end gear, very fast gear, very large and noisy gear like I have in my office right now. So you can probably hear it upstairs. But, so let's go into the distribution layer. This is the isolation point between the core and the access. Sometimes the core and distribution layers can be what's called a collapsed core and distribution, where, again, I speak of logical layers, and even if you were to look at the device physically, you don't see two different devices doing core and distribution work. It's just one box, and sometimes that's okay if one box does that. But here at the distribution layer, policies are enforced, routing and security, static routing, which you'll see two places where I put an asterisk on these slides. If there wasn't a glare and you could see this at all, there's an asterisk. I'm not going to talk about routing today because I only have 10 minutes. But routing happens here. Route determinations are made at the distribution layer. Route redistribution, briefly, if you have two different routing protocols and you want them to talk to each other, that's redistribution. QoS mechanisms, the actual mechanisms that determine QoS are here. The work's going on at the distribution layer. Again, the core's moving everything as fast as possible, but the work of QoS is at the distribution layer, hence the term distribute. VLANs are here, the routing between them. If anything wants to route from one VLAN to another, it has to come to the distribution layer to do that. Aggregation points for physical connections, copper and fiber come here. That's basically what that means. And so that leads me to the next thing. It's a transition. If you have media converters from fiber to copper, they're considered to be at the distribution layer. So I'm going really fast. Is anybody lost or wants me to stop or slow down? Access layer. I said this already, found in closets across campus. QoS packets are marked here. When your phone is plugged into the access layer, it marks its packets with a very specific class of service that says, I'm a phone and you need to prioritize my data because otherwise the phone sounds choppy and distorted. So QoS marking happens here. High availability. High availability is kind of across the board. The motto that Eccles has put forth is uptime is key. We don't care what else is going on, uptime has to happen. Port security. We put port security at the access layer to prevent students from plugging in an unlimited number of devices because their favorite trick is to go to Best Buy and get a hub and see how many Xboxes they can connect. And we have a port security maximum of 10 devices, which I think is fairly generous. Rate limiting, and I put in capital letters here. We don't do this. A lot of people think we do. We don't rate limit anything. The sky's the limit. The only thing we rate limit is the public network, which is separate from our campus network. We rate limit that to keep people from going on there and using BitTorrent. So, but otherwise, you get on there, do your backup and clog the network, that's fine. It's actually, that doesn't happen. So, PoE is at the access layer. If the PoE is power over Ethernet, if you have a video camera, an access point, a phone, and the list is just getting bigger as time goes on, that happens here. Broadcast suppression, that's very important. I mentioned the VLANs earlier. They break up broadcast domains. Again, keeping the bottleneck down to a minimum. When a packet on the network wants to get out, it broadcasts. So we break things up into logical VLANs, which keeps that broadcast quiet. So instead of a person screaming, it's maybe a person screaming in a tinier closet, and no one can hear them. It's the access layer. This is our network as it stands now, and this slide will be available and you can put it on Google, I don't care. It's very pretty, I did it myself. But, and I don't know what you guys can see of this because I'm seeing a glare. The core layers here. We have 5 cores, actually 2 main cores and then 3 little ones in various buildings across campus, and then our distribution layers out here, these smaller boxes, and then the dotted lines, that's the access layer. And that list keeps growing. I actually had to, when I brought this document up to add to a slide, I had to add admissions because since I've done the document, we've built more. You see the interconnections between the cores are 10 gig right now because we want to move that data as fast as possible. We get out to here, some of them are 10 gig, some of them are 1 gig. And future projects, perfect timing, Scott Hildebrand. What are we doing? Well, we're going to continue adding bandwidth to our network. We're going to continue making things faster and better. We're going to leverage new protocols like SIP to move us away from traditional telephone networks and more into a networked environment. We're going to move applications to the cloud. The big thing we're talking about now is integrating voicemail more closely with Office 365. And those are the three biggies. Any questions? Did I go too fast? Good? Okay. Thank you.